Hi, my name is Eduardo Ochoa. My ID is a01787017, and today I'm going to be solving the following circuit using the mesh method. And it's known that to solve by the mesh method, we need to first identify the different meshes. So we have mesh 1, mesh 2, mesh 3, and mesh 4. And all of these meshes are going to have a current flowing through it, going in a clockwise direction. So this is going to be current 1, current 2, current 3, and current 4. Let's start by solving mesh 1. So in mesh 1, we have a 5-volt source that's entering the negative, so it's going to be minus 5, plus 30 ohms, which are only acting on the current, so it's going to be I1, plus 45 multiplied by I1, minus I2, since this 45 is acting on both current sources. For this, we're going to have an equation 1, which is equal to 75 I1, minus 45 I2, equals to 5. Then we have the super mesh, which is going to be comprised of meshes 2 and 3 because they share a current source. So due to this sharing of the current source, we're going to know that the super mesh will have an I3 minus I2 equal to 0.25, since I3 is going in the current source direction, right? Now we have the second equation of the super mesh, which are going to be the voltages involved in the super mesh. We have the first voltage, which is 45, times I2 minus I1. Then we have 54 times I2 minus I4. Then we have all the way over here, we have I3, which is multiplied by 1 ohm, so it's just going to be I3. And this we can equal to 0, which is then going to equal, I forgot to equal this to 0, which is then going to equal the third equation, which is going to be minus 45 I1 plus 99 I2, and then we're going to have a plus I3 minus 54 I4, and we go to the last mesh, which is mesh 4, which has a 54 resistance, and that is multiplying I2 minus I4, I4 minus I2, I4 minus I2, and we also have a voltage which is entering the positive, so it's going to be plus 7 equals to 0. This we can factorize into 54 minus 54 I2 plus 54 I4 equals to minus 7. Then I'm going to grab my calculator and I'm going to input the values. So, right, I'm going to input the equations in order to get the currents, and I'm going to write the currents where you can see them. I'm going to write them down here. So we're going to have the I1 is equal to minus 0.625. I2 is going to equal, it's hard to see, but I2 is going to be equal to minus 0.225. I3 is going to be equal to 0.2, you can see, 0.26. And finally, 0.26. And finally, I4 is going to be equal to 0.035. Right, 5. And with these, we can solve for both Vx and the power in the current source, which I'm going to do over here. So Vx is just equal to the resistance multiplied by I1, which is minus 0.625, minus the other current acting on it, which is 0.225, which is also a negative. And this is going to yield minus 19.35 volts. And then we're going to have the power, which is going to be equal to 0.25, which is the current, and then multiplied by this resistance by the current flowing through the resistance, which in this case is 0.26. 0.26. So we have 0.26 times 1 times 0.26, which is equal to 6.5 times 10 to the minus 3 amperes. Thank you for watching. My procedure.